So yeah, welcome everyone. We have David Heidelberg, who is not only a human but also a software guy by accident. Yeah, and he will be talking about this. Yeah, it's quite long. For your decision to manage custom Debian repository, he's been doing a lot of continuous integration work on the MISA 3D recently. So yeah, I guess he's going to talk about it, and yeah, I'll leave him to it.
Thank you. Hello, and thank you for coming because it's before the dinner, and I appreciate you came. So let me start. A little bit about me. I'm an IT consultant. These days, I'm contracted by Collabora, and my main topic is working on Mesa 3D CI. And except that, in my free time, I'm also a Debian developer. I built some small GPU testing farm. I play with large language models. And I'm trying to make it working on Mesa 3D with OpenCL stack. And I also play with mobile phones and mobile Linux, Mobian, PureOS, and this stuff. So that's a little bit about me. And let's go for the content. So intro, why we need this repository, what was like motivation to make something a little bit non-standard for our project, and then I will talk about what blocks I used to create this repository, and of course the result, and what's going to be next, what's happen in the future. So let's start. So just for people who don't know, Mesa 3D. Mesa 3D is a graphical library, which if you install Debian, you get it with the Debian, at least if you install desktop environment. So it provides Vulkan, OpenGL, OpenCL, different standards, and in Linux world it's standard. On Android it's used sometimes. On Windows it's also sometimes used, and sometimes it's even some part of Mesa is embedded in different software because of some parts which they find useful. So I will be talking about our repository, which is based on GitLab CI. So for the Mesa development, we're using free desktop infrastructure, and we're using GitLab CI directly. What we do is we build containers, and we usually ship these containers to the testing device under the test, and we also send them to the runners in GitLab for software testing, for example, rendering on GPUs, rendering on CPUs, on processors. And in our CI, our images are around like 1 GB of size, and we use a lot of software, which is packaged by Debian. But what we do differently is usually the part when we're using like latest versions. We're using like 3 days old snapshot of the software because some developer are preparing some, new feature, and he needs like the latest tests, latest software stack. But on the other hand, we cannot use Debian testing. We cannot use Debian testing because we are very reliant on stability of our CI, not in terms like Debian would break often, but sometimes Debian breaks or fixes some issue which impacts our tests, and we're running like just in one suite, for example, we have like something like 1 million of tests which run in like timeline of 20 minutes on multiple devices in parallel manner. So for example, if we get some accidental update which fixes something and the developer trying to get his code inside the repository, he would be surprised like why it's like something passing when I didn't touch that. So we need to always like have stable environment, and we need to update only when we want to update, when we specifically decide to update and someone reviews the result without any additional changes. So let's continue. So the challenge. Currently, there is no problem when we rebuild images and it takes 1 hour, and there is challenge, like managers say these days. So the trick is, can we move like our old software building, since we don't use packages for most of our software which is up to date and which is used for the testing, it's usually built from sources. So can we build it outside our container? Yeah, we can for sure make some tarball without dependencies, without nothing, and just put it into our container. But that's not perfect because sometimes we need also track dependencies and we need stuff to build in no order. So, but yes, we can do that. Can we make a repository? Yes, for sure. We just create new repository and we will be pushing packages into it. We can do that. That's still okay. What we had as a problem that like Mesa developers are not always Mesa Debian developers. So since we have few Debian developers in the Mesa, but we don't have everyone, and some people don't care about Debian packaging, some people don't know how to do it, and they not even like want to learn. So we need to somehow make it possible for them to do what they do right now. They just change some hash or they change version number and it builds new version usually if the build doesn't break. So, okay, so what are we going to do with this? No, not yet, requirements. So we have additional requirements on reproducibility, as I said before. So that means like, as I described, you don't want to change anything, you don't changing intentionally. We need maintainability, so they need to easily bump the package. And of course, like performance, when you have to wait like 1 hour for your container build, when you change one line in CI, it's not very comfortable and you cannot work that way much nicely. So we need save time of developers of CI, and we need, of course, like additional bonuses like not destroying planet by running same stuff all over again without any additional result. So the solution I started implementing is based on Git. So it's repository inside Git. So the booing time. So in the end, we used like the large file system support from Git. So the packages are stored as a binary, but it's not just Git push into Git repository. And what is nice about it, if you use GitLab, you can just use this like URL and you will have access to your packages. And as you change the Git hash, you get different set of packages and different state of repository. So what a bonus is, for example, right now, if we're changing to CI and we bump some packages and we're doing another changes after the bumping of packages in the container, we need to like rebuild the container again with older package if it shows up there is some problem or we need some patch. With this approach, we can just change hash of installed packages and the older packages gets installed without additional compilation. So let's go for another slide. So how we did that? Like the issue was maintainability, so developers can do that. So I got recommendation on DebConf in Hamburg, mini DebConf, about using VCS tool, which is very nice small tool. It just you just define the type of repository URL version, and you can also accept version define hash, and it will download recursively the repositories and everything in place, so you don't have to care about that anymore. So that's the good thing. And when the developer needs to update software, he just changes the hash into, let's say, this file. Problem was what about Debian directory? Because we can choose from two options. Follow, for example, Salsa Debian Git repository from Debian directly, or we can just follow the upstream project. So far, I'm using the second approach, following the upstream project, And if Debian packaging exists, I usually just take the Debian directory and inject it into our workflow. Because it's a little bit easier to bump to new version because you change the upstream version of commit or version, and it will just try to build with existing Debian packages, existing Debian structure, which was provided originally. So, the structure is easy. It's just a few GitLab YAML files. Then the main YAML file includes the packages YAML file, and there is few scripts which are executing the creation of the package and pushing it into repository. The design is made, you have like one main branch when you have the definition of the repository itself, and then you have second branch into you push the large file system files, the Debian packages, and the repository itself. So, and for example, the branch Trixie here, it just has standard repository layout created by some tool. How it works? So in our repo, we just prepare basic container, which is like same as a version of Debian as we built for. We do per each package, we create job per each architecture we built for. So it can run in parallel and pretty quick. And so in that phase, we generate sources repos file for the tool I mentioned previously. It gets generated from the YAML file of GitLab. Then we create new changelog entry because we have the timestamp and everything in it. And we build a package. So, and when all the packages finishes in the stage, another stage will publish the repository inside the Git, which is operating in. So it looks like this. It's like very simple. Of course, when you have like many more packages inside, it will be like longer view, but otherwise the structure should be same. So challenges, like for me, there was existing GitHub solution. So it was like not that hard. It was just filling the GitLab pieces to wire it together. What I'm fighting a bit is, so far we have like AMD 64 runners and Arch 64 runners, but we don't have, for example, ARM v7 32-bit old ARM runners. And cross-compilation doesn't work for every package so far. So what I understood is like so far unfixable, but that's for discussion. Maybe you will show me it's possible. I don't know that much to say that definitely. And sometimes we have, for some software which is not packaged in Debian, and we use, for example, some like cross-VM, which is like Google virtualization tool. It's usually the problem that the package itself is trying to download a lot of dependencies on fly when it's building. So it's not very feasible to just easily bump the new revision and like have everything done. And of course, there is like one question which is like, should we use upstream or Debian sources? Because of sometimes Debian patches some issues, and we will probably not have it because we usually just copy the Debian folder from some previous revision. So question is if we have to complicate it and download from, for example, Salsa some way automatically, and risk like that Debian developers change something and maybe it will break for us, or just, you know, download it once and wait until it breaks, which is maybe a good approach, but maybe not. That's a question which will show over time. So results is the original goal is not still achieved. An original goal was like use the CI for our use the repository for our CI, but so far at least I started using it to produce nightly Mesa builds against Trixie. So if you need like find some regression or something, you can just edit it to repository and you get nightly Mesa builds. Something, I don't know if anyone of you is familiar with Ubuntu OIBuff repo. You know, is anyone familiar? Anyone use it ever with Ubuntu? Not really. Okay. Not much gamers here, or at least maybe not Ubuntu gamers. So that makes sense. It was like a repository for Ubuntu, usually gamers, where the guy packages a lot of latest software, latest versions, so gamers can get like high performance and all the fixes. So this can be used also this way, but this repository. But of course, like main goal is like for bisecting or figuring out Mesa issues, because you can do exactly what you do in CI. You just set specific revision. So for example, if you use the repository and today you got broken rendering in your application and you are like, for me it happened a lot of times. I was like, okay, but it worked like 3 weeks ago, 2 weeks ago, it worked. But then like you have to like start figuring out how to get the older packages and everything. And here you can just look into Git repository and you pick the hash like 2 weeks ago. You just downgrade your packages and you can try if it's still broken or maybe it's not related, which is nice feature. So this is like kind of side effect of the work, but so far it's producing images, producing Mesa builds. Sorry. So what's next? I need to get to cross build for every package we use, somehow reliable working, which is limited as we don't have all the runners for all the architectures. And also we're still looking for RISC-V machines, because it would be nice to have RISC-V builds. And of course, I think the interesting area could be, since we're building like always the latest packages usually, which get at some point into Debian. So like, you know, if build system changes and we need to do some changes to Debian folder, it probably can be easily reproduced to like passed to Debian maintainers of the package in Debian and like get them prepared for what's coming with next version, for example. So that's another possible use in future. And yeah, that's all. There is like link for the repository where the work is currently ongoing. It's kind of changing so far still, so it's like not in the stone. And there is original like GitHub CI project from Yoshan, which told me like the basics to begin with on the Hamburg mini DebConf. And thank you for your attention. Feel free to ask questions or start discussion, because you know I know something, but it's always nice to maybe get some feedback and input on this. So thank you, and ask or discuss or go for lunch if you for the dinner if you want to.